All right, so as we continue on with graphing parabolas without a calculator, now we have our first little tweak to this, and it's going to be how do we graph parabolas that are vertically stretched or vertically compressed. So that's what this section is. It's not too different, same idea, just one little extra step. So just like we were able to graph parabolas that moved around, we can easily graph parabolas that are vertically stretched or vertically compressed. All right, so figure out where the vertex is. That's step one. Figure out where the vertex is of the parabola and plot that point, just like we have done before. We're then going to create the parent graph table, just like we've been doing every time so far. The difference now, or the added step, is you will multiply the y values of the parent graph table by the a value of your equation. And then these will be your new movements from the vertex. So your x's aren't going to change, but you'll have new y values, and you can kind of see that on the table here. So if I have this example here, we're going to open, I answer this question, we have y equals 3x squared minus 5. It's going to open up because the number in front of the x squared is positive. It is shifted down 5. It is not flipped. And this is going to be vertically stretched because your a value is equal to 3, which is greater than 1. So we figure that out. So that means our vertex is going to be just down 5. So 0, negative 5. There's our vertex. We plotted that. So that's step 1 is done. Step 2, create the parent graph table. So the parent graph table is, again, the same one we've been doing, going from negative 2 to positive 2. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And remember, that's at our vertex here. We have an a value of 3. So it says multiply by the a value. So I'm going to write times 3, times 3, times 3, times 3, times 3. And we're multiplying just the y values. The x's aren't going to change. So I'm taking the y. 4 times 3 is 12. That's my new y value. 1 times 3 is 3, new y value. 0 times 3 is 0. 1 times 3 is 3. And 4 times 3 is 12. So this column is now the up and down movement. We still have the same left and right movement from the vertex. So if I look at there's my vertex. I'm now going to go left 1 and up 3. Left 1, up 3. Again, that's because the x's aren't changing, still going left 1, but these are my new y values because it's vertically stretched. I'm going to go back to the vertex and go left 2, and now up 12. So vertex, left 2, up 12. And again, we should have the mirror image on the other side. Right 1 and up 3. And then right 2 and up 12. And we have a nice, very vertically stretched parabola here. All right, let's take a look at the next one. This would be a vertically compressed one. It's going to open up still because the a is positive. It is shifted to the left 4 and up 3. It is not flipped, and the a is 1/2, which means it will be vertically compressed. That a is between 0 and 1. Again, we make our parent graph table. And now our a value is 1/2, so we're multiplying everything by 1/2. So 4 times 1/2 is 2. 1 times 1/2 is 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. And 4 times 1/2 is So again, these are the new y values, still the same x values. So my vertex, again, originally was 0, 0 in the parent graph, but we're moving it left 4 and up 3. And so we are going to go left 1 and up a half now, half a block. And then left 2 from the vertex and up 2. Go back to the vertex, right 1 and up a half. And then back to the vertex, right 2 and up 2. And notice this parabola is wider, it's not growing as fast as the parent graph. All right, try doing this one on your own. So this is going to open up still. It's going to be shifted to the right 6 and down -7. It is not flipped and it would be vertically stretched. And you always have the same parent graph table. And our a value is 3. If our a happened to be a negative, guess what? We just write the negative. So if this a was -3, then we multiply by -3. But since it's positive, we're just going to write it 3. And if you write it as a being a negative, if a is negative and you multiply it by negative, that would automatically flip it for you because your values will be negative. Your new y's will be negative, so it means you're going down. So 4 times 3 is 12. 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 3. And 4 times 3 is 12. Again, we plot our vertex first, right 6 and down 7. All right, then we're going left 1 and up 3. And then left 2 and up 12. So it'll take us to the point 4, 5. Mirror image on the other side, right 1 and up 3. And then back to the vertex, right 2 and up 12. So that'd be at 8, 5. Again, notice that parabola is growing much faster. It's a skinnier parabola. Hopefully you got that. All right, last thing we're going to look at then is writing the equation of a parabola given the graph. So number 1, determine. So like you'll be given a graph. How do you write an equation for that? So here are your steps. Determine if the parabola opens up or down. And remember, if the a value is positive, the parabola opens up. So it all depends on the a value. If a is positive, parabola opens up. If the a value is negative, the parabola opens down. Then you want to determine how the parabola is shifted. Remember, the vertex of the parabola is the h comma k. So find that vertex. That vertex was at 0, 0, and figure out where it is at now. And once you know that, you're going to substitute your a, your h, and k into the graphing equation for a parabola. And remember that graphing equation is y equals a parentheses x minus h squared plus k. Okay, so if we look at example 1 here, this parabola opens up, it is shifted to the right 3 and down 4. So that means our vertex is 3, -4, and our h is 3, our k is -4 then. Since it's opening up, we know a is positive. If we just look here, we're going right 1 and up 1, and then right 2 and up 4. So we know that it follows that same pattern of the parent. So it's not stretched or compressed. So our a is 1. Let's just say, for example, if the graph was up here, and I went right 1 and up 2, that means the stretch factor will be 2, because normally it's at 1, but now it's at 2. So just pay close attention to that. So now we have all that parameters, a equals 1, h is 3, k is negative 4. We just plug that into our graphing equation that we have. Y equals a parentheses x minus h squared plus k. So again, a is 1. We can put a 1 in the front if you want. You don't have to. X minus 3 squared. Again, h is positive. When we plug it into that equation, it's going to look negative in the equation, but it's really positive. And then minus 4. All right, example 2. It is going to be opening downward. So that means our a is negative. And if you notice, we're going right 1 and down 1, and right 2 and down 4. So that means it follows the same pattern as the parent, just going down instead of up. So a is negative 1. We are shifted to the left 2 and up 3. So our vertex is at negative 2, 3, which is our h and k. So again, as we plug that into our graphing equation here, we'd have y equals negative 1 as the a, x minus a negative, so that would be plus 2, quantity squared, and then plus 3. All right, there's all the little other parts to graphing a parabola. Enjoy.